Hello and welcome to this lecture on inverse Laplace transform using a partial fraction. We will solve the problem with respect to inverse Laplace transform by using a partial fraction method. So the first problem, they have asked for the inverse Laplace of the function capital F of s. So while going for the partial fraction, I may take s square 3s plus 2. So on multiplying, I should get 2. On addition or subtraction, I should get 3. So how the value will be? So if I am getting on multiplying, so it should be 2s minus 1. If I multiply this, I will get 2. If I add up both, I will get minus 3. The same thing I have did for s minus 1, s minus 2. Then I will go for the partial fraction. S minus 5 by s minus 1 into s minus 2. It can be written as a by s minus 1 plus b by s minus 2. On the next step, we will multiply the terms. A into s minus 2 plus b into s minus 1. Then the denominator becomes a multiple of both. So s minus 1, s minus 2. So the denominator get cancelled. So finally, I will get that s minus 5 will be equal to a into s minus 2 plus b into s minus 1. Then we have to find the values of a and b. So if I put s equal to 2, this term becomes 0. I will get the value of b as minus 3. If I put s equal to 1 and then b will be 0, then I will get the value of a. A will be plus 4. Then I have to multiply the terms and I have to substitute the value of a and b. So here I have splitted the term a by s minus 1 plus b by s minus 2. Here a value is 4 and b value is minus 3. So accordingly I have splitted this. Then while taking the Laplace inverse of both terms, I have to split the both terms first. 3 by s minus 2 by using a linear property. On the next step, Laplace inverse. I may take 4 as a constant. Then I may take the Laplace inverse of 1 by s minus 1 minus 3 Laplace inverse of 1 by s minus 2. So already we know that e power at will be 1 by s minus. I am taking the Laplace inverse Laplace of e power at, it will be s minus 1. So here it is Laplace inverse of s minus s minus a. So Laplace inverse of s minus 1, it will be e power t. So 4 into e power t. As similarly, s minus 2 here it will be e power 2t. So this will be the final answer. Next. So here, how do we do the partial fraction? I may take the term s plus 1 s minus 2 whole cube. So here I may take s plus 1 one time and I have to give the powers in the reduction way. So c divided by s minus 2 whole square d divided by s minus 2 whole cube. This will be the partial fraction. Then we have to multiply the terms. So what I should get here? In the denominator, I should get s plus 1 into s minus 2 whole cube. So already we have s plus 1. So I have to multiply s minus 2 whole cube alone. That's all. Plus b. Here I am getting s minus 2 power 1 time. So I have to multiply this twice and I need s plus 1 also. Then if I go for c, so here s minus 2 is having a power 2. So I have to multiply one time and s plus 1 as one time. Then if I go for d, I have to multiply only s plus 1. So on the right hand side, I may get the expression like this. So then I may cancel the denominator part easily. So the rest of the terms will be as a equation. Now we want to find the value a, b, c, d. Okay, so simply to find the value of a or else b, simply just assume. If I assume s equal to 2, s equal to 2 means a will get 0, b will get 0 and c also will get 0. Then it is easy to find d. So if I equate s equal to 2, we can find the value of d. Okay, then you just see, if I choose s equal to -1, what happens? B becomes 0, C becomes 0, D becomes 0. Then it is easy to find the value of A. Next, we need two more terms. Then you just assume S equal to 0, or else we may equate the quadratic terms. First, we will find these values. See, S equal to -1, we find the value of A. It will be of -1/3. Then, to find the value of B, just see, I am giving another clue. Equate the S cube coefficients. Equate the S cube coefficients. So here we will get S cube. Here you will get S cube. Here we won't get any X cube. So simply A S cube will be there and B S cube will be there. So with this we can find the value. With this we can find the value of B while equating the coefficients of S cube. And already we know the value of A. On substituting, we may get the value of B as 1/3. Next, if I equate 2, I will get the value of D. Then you can equate S equal to 0 because we already find A, B, D. Then with this value, if I equate S equal to 0, I may get one equation. By substituting those three values, I may get the value of C equal to 4. Then at last, I have to substitute all those constants in the partial fraction. And we want to simplify. That means what's the final thing I have to do? I have to take the inverse Laplace. So I'm just taking the inverse Laplace of the whole terms for each term. So on taking this, we may keep 1 by -1/3 as a constant, and then Laplace inverse of 1 by s plus 1 will be e power minus t. It will be of e power minus t. As same, 1 by s minus 2 will be e power 2t. 1 minus 2 whole square, it will be t into e power 2t. 1 by s minus 2 whole cube will be t square e power 2t. So finally, while adding up all these values, I will get the final solution. This will be the inverse Laplace of the given function. Just remember that inverse Laplace of f of s will retain the value in the form of t, that we call it as function of t.